Okay, so what we're going to do now is revisit the quadratic formula and take a look at some very specific topics related to it. The first of which, we're going to take a look at the discriminant and then look at the number of roots theorem to be able to figure out how many solutions we're actually going to get to a quadratic equation. So first of all, what are roots? Well, we've already dealt with them, kind of. When you take your quadratic equation ax squared plus bx plus c and you set it equal to 0 and solve, all the x values that satisfy it, which are the x-intercepts, are called roots. We called them zeros before. So there's three different options. If you think about where your parabola could fall on the Cartesian coordinate plane there, if it actually is tangent to the x-axis, it only intersects the axis once, and therefore is going to have one real root. The next option is if we've moved our parabola slightly away from the x-axis there below it, then you actually get two x-intercepts, which means that you'll have two real roots. And the third option is what if your parabola is placed in such a way that it never crosses the x-axis? Well, then you don't have any real roots, but what you do have are two imaginary roots, and in fact, they will be complex conjugates of each other, so that's kind of interesting. Okay, so what is the discriminant? So the discriminant from the quadratic formula is simply the number that you calculate that is underneath the radical sign. So b squared minus 4ac. So here's the deal. If the discriminant is equal to 0, then there's going to be one real root. And if you think about it, if this number is 0, the radical goes away, there is no plus or minus that you have to deal with. Your root is just negative b over 2a. The second option is if that number ends up being positive, then there's going to be two real roots. And in fact, if it's a perfect square, then your roots are going to be rational, because if this comes out to be something like 25, you can take the square root of it and actually have 5, and then you can actually evaluate this. They become either fractions or integer values. But if it's not a perfect square, something like, say, 15, then you're actually going to have a radical that can't be simplified any further, and therefore it's an irrational solution. So the roots will be irrational. The third option is, what if it becomes negative? So if this number is negative, that means that we have imaginary numbers, right? So that means there are 0 real roots, because they're not going to be real numbers, but they are imaginary numbers. And in fact, they are complex conjugates. Okay, so let's apply it. We're going to determine the nature of our roots. So just looking at this, we're going to plug in the a, b, and c into our discriminant. So b squared minus 4ac. Evaluate it, and all comes out to be 196, which, if you're really good with your perfect squares, you realize is 14 squared. So that means that we get two rational roots. All right, another type of problem that we could do is if they give us a quadratic equation, but k is substituted in there for one of the parameters of a, b, or c, they'll ask you what values of k would you need in order to get a certain type or number of roots. So in this case, what k will give you imaginary roots instead of real roots? So we go ahead and plug in the a and the b and the c into our discriminant, but because we want imaginary roots, we're going to set it less than 0. So we plug all this in, and we just go ahead and solve it. So we end up getting that k is going to be greater than 5. So all values of k that are greater than 5 will end up giving us imaginary roots or complex roots. All right, so we have a number of roots theorem, which says any polynomial equation of degree n has exactly n roots. And as you saw, those quadratic equations, because n is 2, there's always 2 roots. And these roots that you're coming up with can be real, imaginary, rational, irrational, multiple roots. So that means that you could have a polynomial of degree 5 where all the roots are just 3. Those are multiple roots. 3 happens 5 times. Okay. There's also the complex conjugate theorem. I know we've kind of talked about this before in a different light, but what it says is that if you know that a plus bi is a root, then its complex conjugate is also going to be a root. They always come in pairs. So you can't find one complex number a root without the other one also being a root. Okay? So if we had this example where here's my, well, it's not quadratic, but it's kind of quadratic in nature, but it's a degree 4 polynomial equation, and they've told us that 2 of the roots are I and negative 2i. Find all the others. First of all, we know exactly how many we need to find because of the number of roots theorem. It says whatever the degree is, that's how many roots we're going to have. And so we've already been given 2, we need to find the other 2. And using the complex conjugate theorem says that if I take I as a root, then negative I has to also be a root. Same thing, if negative 2i is a root, then positive 2i also has to be a root, because they're the conjugates, right? So the other 2 roots are going to be negative I and 2i. Okay, so then that takes us to the next part that we're going to talk about, which is really from section 9, and now we're going to learn about the sum and product of roots. Okay, so if R1 and R2 are the roots of a quadratic equation, which means think about your quadratic formula, one of them is where you're adding the square root of b squared minus 4ac, and the other is where you're subtracting the square root of b squared minus 4ac. Those are your 2 roots. If we were to add the 2 roots together, this is what that would end up looking like. So here's one version where we're subtracting, and here's the other version where we're adding. So if we add these 2 roots together and simplify this out, the nice thing is that this term and that term are going to add out. They're going to become 0. And we're left with negative b over 2a plus a negative b over 2a. Simplify that down is negative 2b over 2a. 2's cancel, and you're left with negative b over a. So the sum of roots is really negative b over a. Okay, well, we can also multiply the roots together. So R1 times R2. Multiply these together. The numerator, we'd have to FOIL that out, but if you notice, it's kind of like the difference of squares because one's minus and one's plus. So the middle terms are going to drop out. So it becomes this squared minus this quantity squared. And remember, parentheses around that whole thing. If you distribute the negative sign and combine like terms, we get 4ac over 4a squared, which simplifies down to c over a. So these are the 2 formulas that, if we can remember, can be very helpful, nice quick shortcuts for some problems that we're going to have to do. Okay, so the first example of 2x squared minus 4x minus 3 equals 0, find the sum and product of roots. So this is just simply applying those 2 formulas. So the sum of roots is negative b over a. So there's b, negative b, 4 over a is 2, so the sum is going to be 2. And then the product is c over a, so negative 3 over 2. So if you notice, didn't actually solve it, didn't find the exact roots to be able to add or multiply them. I just used the a, b, and c to plug into those formulas. Kind of nice. Okay, next. The sum is negative 5 over 2, and the product is negative 6. Find a quadratic equation. All right, well, if we think about it, they're giving us the sum is negative 5 over 2. So if we set that equal to our formula, negative b over a, we get this nice equation. And then the product is negative 6, so that can be set equal to the c over a. And then we can use this information to help us solve for a, b, and c. If we look here, this is a proportion. You can cross multiply, or would be better is to look at this. If you set a is equal to 2 and b is equal to 5, then we go over here and we plug in 2 for a, we can solve for c very easily. So this is c over 2 is equal to negative 6, therefore c is negative 12. So it's really just checking this out and setting these things equal to each other and then applying that to the second equation. Okay, so now that we have all of our parameters, we can write our equation very simply. Now, let's think about this. Let's take this solution that we just had, and I want you to divide through by 2. So if we divide everything through by 2, we end up getting x squared plus 5 over 2x minus 6 is equal to 0. Well, if you notice something here, the 5 over 2, this is the opposite of the sum, and negative 6 is exactly the product. So opposite of sum, product, which means that you could actually build this equation quite simply by just taking the opposite of this number and plugging it in for b, and this is c. You plug it in, and if they actually want integral coefficients, that means no fractions, you could take this equation then and multiply through by 2, and you end up getting that equation. So just a nice, quick, easy way of doing this if you don't want to do all of this work. Okay? And I believe that's it for now. Hopefully that wasn't too bad and doing 2 sections kind of at once. All right, see ya.